Hello everyone, welcome to the video lecture series on advanced separation process. Myself Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation process. So in this lecture, we are going to discuss about various concepts and working of the microfiltration, cross-flow microfiltration, dead-end microfiltration, application of microfiltration, dialysis, and application of dialysis. So let's first start with concept and working of microfiltration. Microfiltration membrane are used for separation of impurities. The term microfiltration originated from initial use of finely porous membrane for the filtering microbes and bacteria from water and air. Microfiltration is by far the most widely used membrane separation process with a total cell greater than a combination cell of other membrane separation process. Microfiltration has numerous small applications. It is most widely used for the separation of suspended particle matter, bacteria, fragrant cells, and large colloid from solution. Microfiltration is a low pressure cross flow membrane process for separation of colloid and suspended particle in range of 0.05 to 10 micron. It closely reassembles conventional coarse filtration or sieves. It is essentially Stirling filtration with force 0.1 to 10 microns, so small that microorganisms cannot pass through them. A microfiltration membrane is generally porous enough to pass molecule of true solution even if they are large. Microfiltration can also used for sterilize the solution as they prepare with smaller than 0.03 micron. The diameter of the smallest bacteria is 0.03 micron. So, microfiltration rejects particulate, colloids, and bacteria where from microfiltration membrane, water, monovalent, bivalent, multivalent, and acid, amino acids, and proteins and polysaccharides pass from the membrane. Various types of membrane used in microfiltration such as a porous membrane, symmetric membrane, or symmetric membrane. Mostly porous and symmetric membrane are used where sometimes asymmetric membrane are also used for particular application. The thickness of microfiltration membrane is 10 to 150 micrometer where pore size of microfiltration is 0.1 to 10 micrometer. The mechanism of separation is a size exclusion method and various membrane materials are used for the making of microfiltration membranes such as a hydrophobic and partially hydrophilic polymers, cellulose acetate, polycarbonate, polysulfone and polyamide and polypropylene and PTFE. So these all are various membrane materials are used for the making of microfiltration membrane. So there are mainly two types of working of microfiltration. One is a cross flow microfiltration and dead end microfiltration. So first let's discuss about cross flow microfiltration. In cross flow microfiltration, the suspension is pumped tangentially over the filtration medium, clear the liquid permeate the filtration medium and it's recovered as a permeate while the solid accumulates at the filtration barrier to form a fouling layer or cake. In cross-flow microfiltration, the suspension is pumped tangentially over filtration medium and clear liquid permeate the filtration medium and recover as a permeate, while the solid accumulate on filtration barrier to form a fouling layer or cake. The cake constitutes increase in hydraulic resistance and decrease in permeate flux. However, tangential suspension flow tend to limit the growth of cake and thus the after initial rapid increase in cake thickness, the cake grow case and the cake thickness become limited to some steady state value. Correspondingly, after an initial rapid decrease, the permeate flux level off and it either attain steady state or exhibits slow or long term decline with time. So, in cross flow microfiltration, we are applying the flow tangentially or can say that across in this direction. So this accumulate particle will be run off from the surface of a membrane. But after some steady state, the accumulation of particle again on the surface and it make a cake. So when we are applying the flow like this, water can pass through the membrane and the solid particle will be rejected from the membrane and is collected from the retentant, where clear water or dissolved salt are collected from the permeate. So a substance and solvent that pass from the membrane is known as a permeate, and a component that rejected from the membrane is known as a retentant or rejected. So this is how the cross flow membrane works on flat sheet. Now if we are going to use tubular module, then in tubular module the flow is in direction like this, and this pipe is act as a membrane, a solute which diameter is higher than pore size diameter of membrane that will be rejected, and the clear water can pass from the membrane. So we will get concentrate here, and we will get the clear water with salt in this permeation tank. So this is how the cross flow microfiltration works. Now let's discuss about the dead end microfiltration. The dead end mode is analog to a conventional sand filter operation, where intermediate stoppage for backwashing the filter media is required. In dead end filtration arrangement, the feed flow is normal to a membrane surface. The retained particle or solute remain on membrane, forming a cake or gel layer. So in dead end filtration, the flow of feed is like this, where in cross flow of feed in this direction, where in a dead end flow of feed in this direction. So the particle rejected us lay on surface of the membrane, where in cross flow membrane, if we are going to apply in this direction flow, the particle will be run off due to the flow, where in this dead end the particle accumulation occurs on the surface of membrane, and if we want to remove this particle, we have to apply backwash to remove this particle in dead end filtration. So this is a schematic figure for the dead end microfiltration. So this is all about the dead end microfiltration. Now let us discuss about the various application of microfiltration. There are various applications of microfiltration, such as the recovery of cheese brine, pre-treatment of whey milk microfiltration, and clarification of fermentation broth and wild filtration. Then now let's discuss about the dialysis. Dialysis is a concentration gradient based separation process which uses as a semi-permeable membrane to separate species by virtue of their different rate of diffusion through a membrane. So dialysis is work on a chemical potential, or can say that concentration difference. The transport mechanism is a diffusion in force. Separation principle for dialysis is a difference in diffusion rate or sieving. Then, or can say that size exclusion. Size of retained species is 50 to 200 angstrom, and membrane type used in this process is a microporous, where various types of membrane material used for the dialysis, such as a hydrophilic polymer, cellulose acetate, ethyl vinyl chloride, and cellulose corporate. And pore size of membrane in dialysis is from 1.5 to 10 nanometer, or can say that 500 molecular weight. Then module mostly used for the dialysis is plate and fan and hollow fiber. Hollow fiber module widely used for the dialysis process, and flux is near about 12 to 30 liter per meter square per hour for the dialysis process. So this is about the dialysis. Now let us discuss about the various application of dialysis. Dialysis as a attractive separation process when concentration difference for the principal diffusion solute are large, and permeability difference between those solute and other solute or colloid are large. Dialysis is closely related to other membrane separation process using other driving force for separation of liquid mixture. This include electrodialysis and electroosmosis, which depend upon transmembrane electric potential difference, and thermal osmosis, which depend on transmembrane temperature difference. Some of the application of dialysis are hemodialysis, and hemodialysis membrane. So these applications are mostly used for the treatment of kidney patients. This figure shows schematic representation of dialysis diagram, where the solution or concentration is passed from the steric mixture and water is passed from this way. So Degasifier, where degasification occurs, then it's passed from the dialysis unit, where the due to the concentration difference, separation occurs and get useful compound from the separation and reject the and use for the blood circulation again. So this is how the dialysis or dialyzer used. So this is all about the today's lecture. In this lecture, talk about the various concept and working of the microfiltration, then discuss about the cross flow microfiltration and dead end microfiltration, then discuss about the application of microfiltration, dialysis and various application of dialysis. So microfiltration used for the purify the water, and it remove only the bacteria from the water and monovalent ion and other multivalent ion amino acid that pass from the microfiltration membrane. Then discuss about the cross flow microfiltration, in which flow direction is like this on the surface of the membrane, so that the accumulated particle can run off from the surface and we will get the effective permeate flux rather than the dead end microfiltration. In dead end microfiltration, as like conventional filtration, the flow direction is like this. So accumulation of the solute particle on membrane, which result in cake formation. So in dead end microfiltration, we have to allow certain time to backwash the filter. So it's a time consuming process compared to the cross flow microfiltration. Then discuss about the various application of microfiltration. Then discuss about the dialysis, where separation is based on the concentration difference and chemical potential difference. Then discuss about application of dialysis. So this is all about today's lecture. I am completing my lecture here. Thank you.